Hello, and thank you for the interest in CEM's microwave technology. In this video, we're going to be providing an overview of the Liberty Blue system, our latest generation automated microwave peptide synthesizer. The Liberty Blue is a single channel microwave peptide synthesizer. It synthesizes a peptide after the chemist would load the resin into the reaction vessel, and then the system, he would press the start button, and then the system would automatically synthesize the peptide. After completion of the synthesis, the chemist would then remove the reaction vessel assembly from the system and transfer the peptide on the resin, and then they would perform their post-synthesis cleavage. The Liberty Blue system consists of four major components. There's the Discover microwave component that you see down over here. There's the Liberty Blue, which is the fluidics handling module component of the system. Over here we see the external controller with application software that controls operation of the system, and off to the side we'll see the waste system in just a few moments. The major benefits associated with the Liberty Blue system are twofold. Number one is its very short amino acid addition cycle. For a scale of 1/10 of a millimole, the system uses approximately 4 minutes for each amino acid addition cycle. And then the second benefit of the system is its significant reduction in solvent usage. The system uses approximately 50 mLs of solvent for each amino acid addition cycle on a 1/10 of a millimolar scale. So that's a 4-minute amino acid addition cycle with 15 minutes of solvent consumed for each cycle. What this provides is the capability to synthesize a 25 mer peptide in just under 2 hours, and you will generate approximately 375 mLs of waste for that sequence. The system has two optional features that we're not going to discuss in this video. The first is a resin transfer option. The resin transfer option is an add-on to the Liberty Blue system. This will convert your single-channel automated peptide synthesizer into a fast sequential automated peptide synthesizer. This will match up with traditional parallel systems. Secondly, there is a small molecule synthesis option that can be added on to the system. So if you wanted to synthesize peptides and small molecules in your research laboratory, you would have the capabilities to do that. Okay. Now, one other thing I'll mention about the system is designed for peptide synthesis. It can also be used for peptoid synthesis and for PNA synthesis. So it's a very flexible system. Now, what we're going to do first is we're going to take a look at the microwave component, and specifically the reaction vessel assembly where the synthesis takes place. This is the microwave component down over here, and the reaction vessel that I'm going to take out, get my hands in here. This is the reaction vessel assembly that resides in the microwave cavity. It just sits there, and we transfer reagents into and pull reagents out of the system for the synthesis process. Now, this is a 30 ml reaction vessel, and what I'm going to do is I'm going to disassemble it. There's a quick connect on the bottom. It'll make about a quarter turn. Well, maybe a little bit longer. Okay, and then this will unscrew from there. And now what I'm going to try and do is get a close-up of the underside of the reaction vessel assembly head. What we're most interested in is where reagents are coming into the reaction vessel assembly. The sort of the tan fitting is a spray head. This is for DMF. It only handles DMF coming into the system. So all my washes are coming through a dedicated line. Secondly, piece of tubing right over here. This is where my amino acid activator and activator base come into the reaction vessel. So it's a dedicated line coming in there. This little piece of glass tubing, I'm going to turn it to a side, and glass tubing houses my temperature probe. The temperature probe measures the temperature during the deprotection and coupling steps and regulates the microwave input power during those two steps. Okay. Lastly, it's going to be difficult to see, but way down in there into the head there's an opening. That's your vent line. Your vent line keeps the vessel at atmospheric conditions during the reagent add steps, and also the vent line is used to apply nitrogen pressure so I can go through my filtration steps. So that's what I would see on the underside of the vessel. Just on the top side so you can see what's going on again. I'm going to come over here where it says wash, that's where my DMF line is coming in. Where it says reagent, that's where my amino acid, activator, and activator base solutions are coming in. The little blue fiber is my temperature probe that comes into the reaction vessel. The larger line is my vent line. Okay, as I said, the vent line is just open up to the atmosphere while I'm adding reagents, and I will run nitrogen into the reaction vessel for my filtration steps. So that's what the reaction vessel head looks like. This other line is the exit port line, this line right over here. So that's what the head looks like. There is a 30 ml reaction vessel. I'm going to put this head assembly back in here for storage. The 30 ml reaction vessel has a little pigtail. This is the exit port. This is where all the reagents will come out of. Also, I will bubble nitrogen in through here to agitate the reaction mixture. Also, this is where I'll be adding my deprotection base. Will come in through the bottom. So I have a dedicated line in for my deprotection base. A point to note for all of this, I have dedicated lines for my DMF wash, dedicated line for my activator, activator base amino acid solution, and a dedicated line for my deprotection base. This is important. We use this type of design to shorten the amino acid addition cycle. It minimizes the number of wash steps that are involved. And something I don't know if you're going to be able to see, I'm going to try and get a close-up in there. The very bottom of the reaction vessel is a glass frit. Okay, the frit will be used in all my separation steps whenever I'm going through washing steps, drain steps. The resin size that you can work with is 100 to 200 mesh for the resin. Okay, this is a 30 ml reaction vessel. It's good for about 0.075 up to about 0.5 millimolar in scale. I have two other reaction vessels that come with the system. There's a larger reaction vessel. It's a 125 ml reaction vessel. It's good from about 0.5 to 3 millimole. And then there is a 10 ml reaction vessel. It's good down to approximately 0.025 millimole. One thing that's nice about the reaction vessels, you can swap them out easily. So they both have the same pigtail fitting on the end, and they both have the same threads on the top. So if you want to interchange the reaction vessels, you take your reaction vessel head, and this is the way that I would put the 30 ml on. I would tighten it up. Comes in, get a square and make a turn. And I can remove that. Oops. And for the 125, it goes on the same way. It would get screwed in, and if I'm any good, and then I would do the same sort of connector right over here. So that's what I would do with this vessel. The same way with the 10 ml, it would go in, it would get threaded in, and do the connection with the quick connect over here. So that's what's happening with the reaction vessel assemblies. We're going to make one other quick stop over here. I'm going to take a look at the reaction vessel manifold. That goes back in. You'll notice a tab here and a tab here. There's two corresponding grooves that they'll connect into, and it will make about 1/8 of a turn clockwise. We talked about the top of the reaction vessel assembly. We're going to move over to the reaction vessel manifold. Over here we can see where all the connections are made. Up on the top where it says wash. Wash is the dedicated DMF line that's coming in for the wash steps into the reaction vessel. Frit, right over here, that's coming out of the exit port. That'll be going over to our waste. Down at the bottom is the reagent line. That's the dedicated line for the amino acid, activator, activator base. The vent line, The vent is either it's going to be open up to the atmosphere, such as when I'm adding reagents, or when I'm performing my coupling deprotection step. And then I will apply nitrogen pressure through this line to pressurize the reaction vessel for the filtration steps. When I do the filtration, what will happen is I'll open up the fret line and the liquid will come out there. This is the fiber optic temperature probe. It's the blue line that you see going around over here. The fiber optic temperature probe is what I use to measure the temperature in the reaction vessel and control the microwave energy during the deprotection and coupling steps. Next, we're going to cover the 29 reagent storage positions of the Liberty Blue module. This component is the fluidics handling module. It controls the amount of amino acid solution, the amount of activator base that are added during the coupling steps. Now, there's 29 positions that you'll see here. The first 20 are designed mostly for the naturally occurring amino acid. You have 7 extra positions down over here. These can be used for non-natural amino acids. They could be used for, if you want to provide an alternate activation scheme, you could place down over here. If you would want to perform capping, this would be a location where you might put a capping reagent. So that's the top 20 are for the naturally occurring. You have 7 extra positions. And then down over here is where I have my activator and activator base storage. Okay? The recommended activator and activator base that we use for the Liberty Blue is a DIC with Oxima or a DIC with HOBT. This allows us to perform the coupling steps at 90 degrees C, and the coupling steps are typically 2 minutes for the majority of our amino acids. The only ones that would be a little bit different would be the arginine. Arginine, we're doing a 4-minute coupling at 90 degrees C, and the other one would be histidine. There's histidine down over here. The histidine we will do at 50 degrees C for 6 minutes to prevent racemization. Otherwise, all the coupling steps with the DIC, Oxima, DIC, HOBT activation scheme are done for 90 degrees C for 2 minutes. Now, the amino acids are typically prepared as a 0.2 molar solution. Okay? The DIC right over here is prepared as a 0.5 molar solution, and the HOBT or Oxima is prepared as a 1 molar solution. They are added in the ratio of a 1:1:1 ratio, typically added in about a 5-fold excess. However, as you get to larger scales, the excess decreases. Now, the way that these reagents are added into the reaction vessel is based upon a pressure change. The way they're added, you will pressurize your storage container. Now, one thing you should note, I have vessels vessels on each of my positions. There's only one pressure source for all 29 positions, so I need to have a bottle on my storage container for this to work. And so what I'll do is I will pressurize my bottles, and then I will open up a liquid valve on the discharge side of my bottle. And what I have is a piece of tubing that's at atmospheric conditions, and on each end of the tubing I have a pressure sensor, so I can measure the pressure change in that tubing as the liquid valve opens. What's going to be happening is the liquid valve opens, it will flow into the tubing, it will compress the gas in there, and I will see a pressure increase. I calibrate my pressure changes to volumes delivered from the 29 storage positions. We found this to be very accurate and very reproducible. So the pressure add technique is what's used for the 29 storage positions. Now, you might want to take a look at these positions. We'll typically use a 50 ml conical tube for our amino acid storage. There's also a larger size. You can use a 125 ml vessel. The 125 ml storage container has the same threads, it's just wider. And what I'm going to show here is that's the filter that's used on the bottom of the reagent dip tube. This is the filter right down over here that you're looking at. your filters are probably going to have a life of approximately 3 months. So the filter goes right back onto there. Your amino acid solution would go on here and it would be threaded on. Okay? Activator and activator base are the same way. I'm going to take out the activator base bottle down over here that we would store the Oxima or the HOBT. Be the same. Tubing's a little bit longer because my bottle is a 250 ml bottle that we use for this type of storage. I'm going to get that threaded back on again. One other thing I'll comment on, our recommendation for activation scheme is DIC Oxima, DIC HOBT. If you want to use a phosphonium or an erminium activation scheme, that's perfectly acceptable to do. You'll probably end up doing your couplings at 75 degrees C instead of the 90 degrees C that we use with the DIC. So that gets us how we handle the amino acid solutions and the activation scheme. Next, we're going to move over to the common reagents, the main wash, and the deprotect, and we'll take a look at the waste lines as it's all on one side of the system. Next, we're going to move over to the common reagents and the waste, and also the nitrogen pressure coming into the system. So I'm probably going to start with the nitrogen pressure. This is the left side of the system, the Liberty Blue system as we would be facing it. You'll see on the top of this manifold is nitrogen input. This is the nitrogen input. You'll get 10 feet worth of tubing, and you'll go on to a little fitting such as this, and I'll probably put this on your nitrogen supply to do the connection. So thread into your nitrogen supply, and then I'll do the connection just like that. So we'll get the nitrogen flowing into the system. The requirements for the nitrogen, I probably suggest to get about 30 to 40 psi input into the system. The system contains a secondary pressure regulator that will control pressure that is being delivered to the rest of the system. That's usually set at about 16 psi. Okay, now what I want to look at is the next two common reagents. This is the main wash solvent bottle, and this is the deprotection bottle. Okay, the volumes delivered from the main wash and the deprotection solution are different. We use a different technique than we do for the amino acids activator and activator base. These are just timed additions. Okay, the bottles will be pressurized to about 16 psi, and then the liquid valve will be open for a specified period of time. This is calibrated. You'll do this calibration step about once a month to verify the flow for the main wash solvent and for the deprotection base. And I'm going to try and show something. It's going to be a little bit busy down over here, but down here, this is the nitrogen supply going to the deprotection bottle, and this is the liquid line going to the deprotection bottle. So I'll pressurize the bottle coming out this way, and liquid will flow this way. Just above that, this is the nitrogen pressure for the main wash bottle. This is the liquid for the main wash bottle. So nitrogen will come out of this line into the bottle, liquid will flow this way. Okay, now all this other is very busy over here for this tubing. Okay, there's 3 tubes right over here. I'm trying to hook them up. These I've got run over to my fume hood. These are just going to be gaseous waste that's coming from the system. Okay, down over here you're going to see 5 connectors. The 5 connectors go down this line and they go down to my liquid waste container. Okay, there's one primary liquid waste, and then there's a couple other small residual ones. Okay, down over here is the level sensor for my waste container. I'm going to pick up my waste container bottle that I have over here. It has a level sensor in it. If the liquid level gets too high, it'll activate the level sensor. This will shut operation of the system. So if my waste bottle gets full, the system will not continue in delivering waste. Now you notice I have a 1 liter bottle here for waste. There's 2 other sizes that you can get with the system. You can get a 5 liter bottle and you can get a 20 liter bottle. Probably recommend working with about a 5 liter waste bottle for the Liberty Blue system. So that's what I'm going to check out on this side of the system. Next, we're going to take a look at the back side of the system. I just want to show you what's going on there. Okay, during this section what I want to do is I want to bring you under the skin, and I'm going to take the cover off of the unit here momentarily. And I've opened up the back doors. Things that I want to point out here, I'm going to come in through the top. There's 29 liquid valves here, that you can see those. Those are the 29 liquid valves for your amino acid activator and activator-based solutions. Okay. Down over here, I'm going to point in here, this little aluminum block, that's your nitrogen manifold. Okay, your nitrogen manifold is controlling your nitrogen pressure distribution to all the needed parts of the system. When I want to pressurize the main wash bottle, when I want to pressurize the deep protection bottle, when I want to pressurize the amino acid storage positions, when I want to pressurize the reaction vessel, when I want to bubble gas into the bottom of the reaction vessel. That's what I'm going to be doing there. I'm going to point out to these two guys. These are these pressure sensors. They're called pressure sensor 2 and 3. These are on each end of the tubing for the amino acid storage positions. Those are how I measure the pressure to control the volume delivered for the amino acid solutions, activator and activator base. Over here I'm going to change hands. This is rotary valve 1, rotary valve 2. Rotary valve 1 controls reagents going into the reaction vessel. Actually, it controls the amino acid solutions going into the reaction vessel. Amino acid solutions, activator and activator base. Rotary valve 2 controls stuff happening on the bottom of the reaction vessel. When I want to bubble gas into, when I want to drain from, when I want to add my deprotection base, they dealt with through rotary valve 2. Over on this door panel is the secondary regulator. This is my nitrogen gas line that comes in, usually set at about 16 psi. Over on this side of the system is the main CPU. It's right over here. And this is the valve board, and this is my temperature sensor. It's protected. I have a little splash shield on it. Then if I go down to the bottom, you're going to see the back side of the Discover system. This is my temperature system sensor that's plugged in here. You can see the Ethernet cable, and I'll show the router in just a minute. My power cord, you can see, plugs into the back of the Liberty system. So everything goes through the Liberty system, and then the main power goes out to the wall outlet. So that gives you an idea, once you open up the back cover, what you would expect to see. I'm going to close the door just a second. Oops, got it going the wrong way. I've got a router. The router controls the operation. I've got 3 Ethernet cables. One is going to the Liberty system, one's going to the Discover system, and the main line is going over to my computer. And we're going to take a look at the computer in just a moment here, because I want to show the application software. The last section I want to cover is the application software, or the brains of the Liberty Blue system. The Liberty Blue system comes with an external controller and the Liberty Blue application software. It communicates to both the Liberty Blue and the Discover through a router. Okay, the application software controls the operation of the Liberty Blue system. What you would do is you would tell it what the sequence is that you're going to run, the scale that you want to run, and whether it's going to be a peptide acid or a peptide amide, and then you would press the start button. At that point, the system will swell the resin, run all the amino acid addition cycles, and then if you've want a final deprotection or not, it'll do the final deprotection and do the final washings, and it will have the peptide on the resin waiting for you when you come back. So thank you much for your time. I appreciate it. Again, let me emphasize that this video is to be used as a supplement to information you get from our product literature and the CEM Corporation website. If you have any questions, please don't hesitate to call your area representative.